Okay, a little bit more here. I do want to go ahead and cover cosecant, secant, and cotangent because really all they come down to is flipping your fractions. So I think that the key thing to remember here is that cosecant goes with sine and secant goes with cosine. If you can keep that straight, then I think you'll be fine with this. So cosecant of, we have pi over 4. So pi over 4, you can see, is right here, this angle. And the sine of pi over 4 is the y value. And the nice thing about pi over 4 is sine and cosine are actually the same. But the sine is square root of 2 over 2. So what I'm going to do is take that square root of 2 over 2 and flip it. So it's going to be 2 over square root of 2. So we just flip the fraction for cosecant. You do have to rationalize your denominator when you flip. So we will multiply by the square root of 2. And what we're going to get is 2 square root of 2 on top. On bottom, we have 2. The 2's cancel out, and we just get square root of 2. So flip it, simplify it if it simplifies. All right, now we have 3 pi over 2 for the secant. And remember, secant goes with cosine, so we're looking at the x value. So right now we're down here. 3 pi over 2. The x value here is 0. So the cosine of 3 pi over 2 is 0. Now, when we do secant, this is going to make something interesting happen. What is the reciprocal of 0? Well, if you think of 0 as a fraction, that would be 0 over 1. Or it could be 0 over any number, really. But 0 over something gives you 0. If you flip that, if you do the reciprocal, you get 1 over 0. Or whatever number over 0, and the point is you end up dividing by 0. And as we talked about when we did domain, you can't divide by 0. So what happens is you get like 1 over 0, and that's going to be undefined. Now this doesn't only come up with secant. There are places where the cosecant would be undefined because the sine is 0. So like at 0 radians or at pi radians, that would happen. There would be times when the tangent or cotangent would be 0. So, would be undefined. I'm sorry, would be undefined. So sine and cosine will always give you a value, but the other 4 can be undefined because you could have situations where you divide by 0. Let's do one last one. Cotangent of 11 pi over 6. So we're going to find 11 pi over 6. That's you'd go like all the way around, almost till you're back to the start, and you land right here. And so tangent is sine over cosine. So cotangent, what you're going to do is you're going to just flip that. You're going to put the cosine on top and the sine on bottom. So you put the x, the square root of 3 pi, or square root of 3, there's no pi, square root of 3 over 2 on top. You put the negative 1/2 on bottom. As before, these 2's cancel each other out. And we get square root of 3 over negative 1, which is just negative square root of 3. So for cotangent, just instead of putting the y value on top, you're going to put the x value on top. So I'll write that up here just as a reminder. Cotangent of theta is going to be x over y, because tangent was y over x. So that's how you find secant, cosecant, and cotangent. I want to do 3 more examples with negative angles. So I'm going to actually flip back to what we've already did because we don't need to do this again because we have rules we can use. And so what you'll notice, this is the same little box of rules that came up on the previous video. And you'll notice on the bottom you have cosecant, secant, and cotangent. And you'll notice that cosecant matches sine, secant matches cosine, cotangent matches tangent as far as the rules for the negatives. So cosecant of negative pi over 4. Well, let's look at what cosecant of positive pi over 4 was. It was square root of 2. The rule says that for cosecant of a negative angle, you take the cosecant of the positive angle, which was square root of 2, and then you make it negative. So we're following this rule right here. For secant behaves like cosine, and cosine, the sign doesn't change. So for secant of negative 3 pi over 2, let's look what we had for regular 3 pi over 2, it was undefined. And when you're undefined anyway, signs don't really matter, but it's going to stay undefined. So it won't be affected, but even if it was a regular number, you wouldn't change its sign because secant and cosine don't change their signs. If you look at cotangent, that follows the same rule as tangent, so you do change the sign. Cotangent of positive 11 pi over 6 was negative square root of 3. So when you're changing it to negative pi over 6, you just get rid of this negative sign. You change the sign. And it's just positive pi over, or positive square root of 3. Sorry, I'm tongue-tied today. I hope that didn't mess up your understanding of this, though. So cosecant follows the same rule as sine. And to find cosecant, you take the sine, the y value, and you flip it. Secant follows the same negative rule as cosine. To find secant, you take the cosine, the x value, and you flip it. Cotangent follows the same negative rule as tangent, and to find it, you take the cosine over the sine or the x value over the y value. So there you go with cosecant, secant, and cotangent.